Okay, hello everyone. So this is yet another standard LXD release stream, this time for LXD 4.13. As you can see, we've actually made that release on April 10th, so it's been a little while, but I was off all of last week, so had to delay this stream a tiny bit. This release has quite a few new features, some of them a bit more visible than others, but we can go through those and then I'll do a demonstration for all of those that I can actually demo. So the first feature we have here is the ability to easily filter through LXD list. So we already had some ways to filter based on instance names and config keys, but now there are a bunch more filters that you can use. So that's been quite nice. Got support for Nvidia multi-instance GPU devices. Added support for a global configuration file that applies to the entire system. Got support for project resource usage, which now shows both the limit and the current consumption, so you can easily see what you're gonna be running out of soon. New flexibility around snapshots, so you don't need to use cron patterns, but you can use some easy aliases for common kind of times like hourly, daily, weekly, monthly, yearly, or even at startup. Also added support for choosing a default architecture when you're dealing with a cluster that's running multiple architectures. So especially for most people when mixing Intel and ARM. Made a bunch of commands a bit more consistent with their list output and the columns we show by default. Did some amount of renaming around the feature we landed in LXD 4.12. So we added oven ACLs, network ACLs for oven networks back then. Was getting some early feedback and kind of seeing how things go. We had to rename a few things and reshuffle a few things. So we've done that in LXD 4.13. LXD stop can now support the console output so that you get those last few seconds of your instance just as it's going down. And automatically generated REST API documentation has been extended as well now to include more API endpoints. We're still missing a few, but getting there. So that was a very quick overview of what's new. Now let's go and look at the terminal and kind of go through those features. Just before I do that, I just need to actually go prepare a machine for when we get to the Nvidia part of things, because I did grab the machine, I just didn't deploy the drivers on it yet, so I'm just going to be doing that real quick, and then we can go through what's new. So just transferring over, trying to transfer the driver, but apparently the machine is not responding. Well, that's boding well for the Nvidia demo. Let me see what's going on. Okay, it shows us deployed. But I can't reach it. It's refusing SSH, so that's special. Yeah, not completely sure what's going on there. This is unusual. Let me try rebooting the system, and then worst case I won't be able to demo that, but that would have been a nice demo. It's the one system that has a Nvidia GPU that's capable of doing multi-instance GPU. So it would have been nice to get that. Anyhow, for now, let's just switch over to a terminal here and we'll start looking at the other features first. So, first thing first, let's just switch to my local remote and look what I've got. So I've got a bunch of just containers and VMs running locally. The new feature now lets you do things like, so what you could do before was, if you want everything that starts with CentOS, you can do LXD CentOS and you get just those. That worked fine. You could also do image.os equals, I think Ubuntu is it, to filter based on some config keys. That also worked just fine. The new features now let you do filtering on some of the other fields that are not simple config keys. So you can do list of all containers only, or virtual machines. You can also do only want the running ones, so you can do that. You could do architecture. I mean, in this case, on everything is going to be x86-64, so it's not the most useful. But if you have a mixed cluster, you can do that. If you're on a cluster, you can do location, but for that, then we need to switch to a cluster. Okay. So now I'm on a remote LXD cluster, and I can list based on location. So I can do location, say everything on Abydos, and there you go. You can filter by subnets as well. So in the case of this server, it's kind of using two different subnets. If I want to list everything that's in one of them, I can do, say, this subnet and /64, and it lists all the instances that have an address in that particular subnet. Or you could do it on IPv4 and be like, I just want all the instances that have this specific IPv4 address, and there you go, you get that. So that's quite nice. It's quite flexible. We might add more filters later, but I think the current set is really going to be useful for a lot of people. The next feature would be that Nvidia Demo, but I don't know if my machine's decided to like me yet. Let's see. No, still getting connection refused on it. So that's a bit special. Give me just a minute here. I'm gonna try to see what's going on its text console. See how it goes. Just connecting to the remote KVM I've got downstairs to see what's going on, because no, it's a clean deployed Ubuntu system. It should boot, it should answer the network, and it does, just doesn't let me SSH at all. As if SSH didn't start, which is a bit bizarre. Just gonna check something. Yeah, it's as if it deployed Ubuntu, but didn't bother to deploy SSH on it. So that's gonna be a bit problematic. What I'm gonna do is I'm just gonna be redeploying it while I show other features, and hopefully this redeployment will actually work and get me working SSH. Okay, deploy 2004, yeah, go. Okay, so that machine is deploying again. Hopefully second time will work a bit better than the first. It's kind of confusing. It picked up that new terminal, didn't want? Okay, all right, back to the right one. So let me go back under the feature list, and the next feature after that will be system-wide remote configuration. That's not going to be that's not something I can actually show because I'm using the LXD snap and we've not added support for that yet, but basically you normally have, well, for snap users it will actually be in there, current. Okay. So LXD has that config.yaml config file. We've now added support for having a global one on the system. So for those not using the snap, it's in etc LXD config.yaml. For those using the snap, we're probably going to be using a path on the var snap LXD command. The idea there is that you can put a config.yaml listing a bunch of remotes with the certificates, and it will those remotes will always be present for any user. The user will be able to copy the remote if they want to override it in some way, but otherwise it's there by default, which makes it very easy to have a system, like pre-configure a system for all its users in one go. But as I said, not something I can actually demo because that's not working with the snap yet. the project usage that I can demo. So say I switch to a restricted project on my remote cluster. If I show the config for that project, we'll see that it's limited to 4 CPUs total, 50 gigs of disk, 4 gigs of RAM, 10 networks, and 100,000 processes. In the past, that's all you could see. You could see those limits. You couldn't really do anything else. All that will happen is that if you try to exceed it, then you would be getting an error. Now, what we've added is LXD project info, which shows you this table, and that shows you what the limit is and how much you're currently using. So in this case, this project is not limited at all in the number of instances of either type, but it has everything else limited. So you can see what our process limit looks like. We see we've got one network out of the 10 we're allowed, using 3.2 gigs of RAM out of the 4.3 that's allowed. Just 3 instances, but yeah, it's unlimited. Disk space being used, and the CPU. One thing to mention here is that it's not comparing your actual live usage, it's comparing what you allocated. So to such a restricted project, whenever you create something, whether it's like a volume or an instance, you will need to say how big you want this thing to be. You will need to say how many CPUs and memory you want for anything. You will have to say how many processes you want, so that it can be counted towards your quota. There's no good way to actually apply a limit that would work live on your actual consumption. So instead, it's applied to what you're allocating. That gets, like, doing it live would have been potentially possible on a single system, but it would have gotten extremely problematic when dealing with a cluster, because like you need to start tracking how much memory you're using for a given project across multiple systems, and then seeing if you're starting to exceed that, and if you are, then what do you do? Do you start killing things? What happens? So it was far easier to instead put a limit on what you can allocate, so that you can never get in a situation where you actually exceed your quota. Anyway, that's the new feature for project limits and current usage. The next feature we have is around snapshot aliases. For that, I can switch to one of my other projects. Let's go back to core, I guess. All my instances tend to have a configuration where they get snapshotted every day. In the past, I used to use a cron pattern for that, but now I've got, where's the, yeah, it's coming from a profile. There we go. So now we've got snapshot schedule add daily. The nice thing with using add daily instead of using a matching cron pattern is that it will not trigger at the same time every day for every single instance. We effectively use the instance identifier as a seed for a random number generator that then generates a stable time for that given instance to be snapshotted out every day. That means that your snapshots will end up being spread across, like spread over time during the day or during the week, or during whatever your interval is. The other thing, if I switch back, I guess, to my local system, and take a random instance, I guess we can use that D1 instance. Okay, so there is a new target we can use, which is a snapshot schedule at startup. And right now, if we get that instance, it won't have any snapshot, but if we start it, now it does. And if we restart it, it gets another one, etc. So every time the instance starts, you get a new snapshot. That can be quite useful. If you don't want to actually make a daily snapshot, you can do at startup, and every time the instance is started or restarted, you're gonna get a new one. We're also currently working on letting multiple schedules be used together, so that you can do comma separated and do I want a daily snapshot and I want on every startup as well. So we're working on that. It should be there very soon. The next feature on that list is another one that's not really practical to demonstrate, because my cluster is running a single architecture. So if I do this, we can see that the entire cluster is running on Intel. But if I had a mixed architecture cluster, we now have a new config key called images default architecture, which lets you set what architecture you want used by LXD if you do something like this. So right now, if I was to run that on either my cluster or locally, it's obviously going to be Intel. There's no other architecture it can possibly pick. But if I was using a mixed architecture cluster, if that gets deployed on an ARM64 machine, it will be ARM64. If it gets deployed on an AMD 64 machine, it will be AMD 64. The issue with that is that the user might not actually know where the thing is going to land and might get kind of surprised. It's not the architecture they were expecting. So with the default architecture, that means that unless the user specifically asks for an ARM image or specifically targets an ARM node to run the instance will instead go on an Intel system and pick the Intel image. So that's to kind of make things behave kind of more the way people expect it, I think, where they might have usually a pretty large Intel cluster with a few extra nodes from different architectures. For those, they should only be running workloads that you actually want to run there instead of just, taking some of the random ones in the cluster. The next feature we've got on the list would be a bit of cleanup did in the CLI. So in the past, we already had, which one was it? Network, I think. Network list already had the description column. Actually, so if I switch to my cluster, it's more descriptive over there. Okay. Here we go. Just cleaning that up. There. So we can see there's a description column there. There wasn't one in a few other places. So now it's consistent. Consistent enough. So there is a description column in network. There is a description column now in profile, in project, and in storage. So it's visible everywhere. The only place where it's not visible by default would be list, but it is available. You just need to turn it on as a column down there. So now, you get a description column everywhere that you can list stuff in LXD. And for those, you can always, so if you need to edit the description, you can do that with the edit command and then go there and change the description field through that. The next feature, it's not really a feature so much as like we wanted to really announce it, is the rename of those oven security ACLs, network ACLs, config keys. So what used to be a config on the ACL itself, it was called default action or default logged, has now been moved to being a config key on the NIC or on the network called security ACLs, default egress action, default egress logged, default ingress action, or default ingress logged. The reason for that is kind of twofold. The first thing was applying those ACLs directly, applying those options on an ACL didn't make that much sense, because you might have multiple ACLs applied, at which point which one is actually the default. The ordering was problematic for that. The other thing was that there was no distinction between ingress and egress, and quite often what you actually want is you don't want to log any blocked ingress, because that's just someone on the internet scanning you or something. But you do want to log any blocked egress, because that should not happen unless something is badly configured or you've got some suspicious activity within a network. Similarly, with the actions, you might want to reject reject any egress that doesn't match, but drop any ingress that doesn't match. So having the split there makes things quite a bit easier. The stop with -- console, I guess that I can show again. If we switch back to local and we stop that D1 container with -- console, we get to see just the end of the shutdown sequence. The same is possible for VMs. You can even do console equals VGA to get the graphical output. That lets you see if anything is hanging, if there's anything weird being logged during shutdown. That makes it easy to get that without having to run two different terminals just to get that console output. And the last thing on the list, I just need to switch back to the web browser, is the API documentation. I showed that last time already, but we've added more endpoints in there compared to last time. Like all the images stuff is covered now. Network ACLs are all covered. So we're slowly adding everything in there. We're still missing, as I said, instances and storage pools are currently missing. Hoping that they will both be in 4.14. And at that point, we can phase out our old API documentation, and that will become the new official one. And that's it for the features in LXD 4.13. I'm just gonna check real quick if my Nvidia machine decided to come back to life. Looks like it did. Okay, cool. So I just need to push some drivers to it real quick, then I can demo how that works. So yeah. So it's Mascano, and I want IUMMU and Nvidia vGPU thing. Yeah. Okay, so it's installing the. Oh, it's pulling and installing the Nvidia driver now. So I should be able to demo that stuff very soon. Basically what it is, so I can do a quick intro while I'm waiting for the system to get ready. The very recent Nvidia, well, not so much graphics card as compute cards or whatever, based on Ampere, so the A100 card specifically in this case, supports hardware splitting effectively. So you can take the one card and split it into a bunch of different instances of the GPU, and then assign that to containers or virtual machines. So for that in LXD, we've extended the GPU pass-through support feature we have to add a new GPU type here called MEG, so multi-instance GPU. And that lets you then specify what your GPU instance is, what your compute instance is, what the GPU itself is, and attach it that way to containers. So you can still do the old way where you get the entire GPU being passed through, but now with this, you get to pass just a subset of that GPU, if that's what you'd like. Let's see. The machine has the driver installed, just needed to boot back into an OS. And then I can do a quick demo of that. Okay, it's pinging. And let's switch over to it. So I'm just setting up LXD on it real quick now. Here we go. Now let's do the most basic of LXD inits. All right, and let's see what the GPU looks like. So we can see Nvidia SMI reports an A100 in that system. Currently, multi-instance GPU is disabled. We can fix that way. I'm just looking for some instructions. I don't actually remember all the commands that are needed, but we've got daily testing, so I'm just gonna get from our CI repository the actual code we run. Okay, so Nvidia SMI MIG LGIP, that lists the GPU profiles, so we can see what profiles are available. Then we've got in the test, what we're doing is we're creating a bunch of GPU instances. So that's creating one GPU instance that's using the 2G 10 gig profile, then one using the 1G 5 gig profile, and another one using 1G 5 gig profile. So that's creating those three instances. Now those are GPU instances. We still need, and we'll see them if we do LGI, but we need a compute profile, which is what that next command is, LCIP. So LCIP lists the compute profiles that are available. It kind of depends on the, like, not all GPU instances support multiple profiles, but some do. And what we'll do in this case is, yeah, okay, let's copy paste that one. So on the 1G 5 gig GPU that got created, so on this one, so that's instance 7. So on this one, we're gonna be picking the 1G 5 gig 1G 5 gig profile. So we do that. I think we do the exact same thing on the 13 one, from what I remember. We do, and then where things get a bit funnier is that larger allocation we got. So that's the that's 2G 10 gig one. We've got options there. We can either get it as a single thing, so the single 2G 10 gig compute instance, or we can do it as two 1C 2G 10 gig instance, and that's what we're gonna do here. So we're taking the GPU instance number 5, and we're splitting that into 2 compute instances, and that's it. So now they're all created. I think usually we just do SMI after that, yeah. So now if we run Nvidia SMI, that output looks quite a bit different because the MIGs are now all showing up here. And we can see that there are 2 that are fully separate and reasonably small. So it's those 2. And then there are 2 that are sharing a GPU instance. So that's why this block here is not split. It's because the compute is distinct, but the GPU instance is shared. So that means that they're sharing memory effectively. Instead of having their own dedicated chunk, they're actually sharing. At which point we can do, let's take Ubuntu 2004, create a container called U1. We want to enable the Nvidia runtime. So it's just gonna create that container. With Nvidia runtime enabled, the tools and libraries that are needed will be passed into the container. So now if we run Nvidia SMI, it's there. There's no GPU, but Nvidia SMI is there. For MIG, you need to stop the instance. We can't do it live, unfortunately. But with it stopped, we can now do U1, GPU 0, the type is GPU, GPU type is MIG. And let's say we want to pass, which one can we pass? Let's pass this one. So this one is GI is 7, CI is 0. If I don't do typo, it's gonna work better. MIG CI 0. And the card itself, so that's all coming off 0900.0. That's the address here. I had to skip the beginning. So that's added. Now if we start it, we've got just that one GPU added to it now, so that's fine. Then if we wanted to pass the second slice for that, no, that was like one of the distinct ones, okay. So let's instead pass one of the 2 slices of the shared one, so that's 5, and say we want to pass the second slice of it, so that's 1. And there we go. So now we see we've got 2 GPU instances, compute instances passed into that particular container. It's getting the one that's at GI7 CI0 and the one at GI5 CI1. So for anyone who's got access to that kind of GPU and wants to really separate and have containers that cannot see the GPU memory of others that are scheduled fully separately for that GPU workload, it's not perfectly possible with this. It's quite flexible. There are plenty of profiles, and you can really split things kind of whichever way you want. And that's it for what I had to cover for 4.13. I saw at least one question in chat earlier, so I'm just gonna be taking a quick look at that now. So are there any plans to have limit applied to all containers in a project without having to specifically limit each one of them, but they all share the resource pool? No, so that's what I kind of got to. It would have been, we were thinking of doing that at the beginning. Our thought was that on the single system, we could create control groups, assign, say, if you wanted to limit the memory of the project to 8 gigs, assign 8 gig to that control group, and then put all the instances for both containers and VMs in that control group. And whatever you do, you can't exceed that 8 gig. That was our thought at the beginning. The problem is it doesn't work with clusters, because as soon as you start clustering, C groups are a local single host kernel mechanism. There's no way for us to say, hey, you actually get 8 gig of runtime memory across 5 machines. To do it, what we would need to do is like constantly track the memory usage on every single one of the systems, and as soon as you start exceeding it somewhere, then go and like kill processes or do something like that, and that just wasn't practical. So instead we kind of looked at what the public clouds and OpenStack and some of the others have been doing, and the conclusion was your limit applies to what you allocate, it doesn't apply to what you use. It's a bit unfortunate, but that's really the best we can do. And yeah, that's the only question in there. So thanks everyone for following along. I hope that that LXD 4.13 will be quite useful to you. That there should be features that are kind of useful for everyone. If anything, just that LXD list filtering feature at the top is really neat. And yeah, like we're extremely busy right now because of hiring and having to wrap up a lot of different features in LXD. So I've not found a lot of time for blogging and for those live streams. I'm hoping this will change in the next few months and that we get to bring back live streams about something other than just a new LXD release, that we get to show what our users have been up to. I've got some plans of showing like how to use LXD from Windows, how to use LXD from macOS. I've been using LXD quite a bit ever since I got a new Chromebook. Just playing with the integration on Chrome OS has been quite neat too. I think a lot of that would be nice to show to folks on YouTube, and I'm hoping we get more time to do that kind of stuff. But for now, thanks very much for watching this. If you got any questions, please just leave a comment, and see you in the next one.